Next question. Great. William. Tell me, are you getting it?
Just 1 minute, I'm reading something.
Okay.
I'm just talk to the process and talk to the bottom of the then this
So, what are you getting finally?
so we get food company like we the work done by F1 will be F1 R jobs only.
Okay.
And the top of the work done by the particle of the watch. And the work done by the F2 into R jobs.
Yeah, correct. That's it. F1 into R, F2 into R.
Yes.
Try this.
The particle of mass
Question is visible?
it is clearly visible.
Okay. So, what you are saying?
So what's this means so what is the very cable. They are not to relation to the particle. Finally, thermal gravity is a rate. Thermal gravity is the energy of information. Work done by gravity as it is a displacement. Then you have to follow the equation. For example, work for the operating displacement. Also, there is a displacement condition.
Okay, got the answer?
So displacement find 1 minute is 0 cos
Sorry.
theta to the r of displacement. Sir,
Hmm.
MGR, sir.
Hmm.
Sir, MGR is the work done by the gravitation force.
Yeah, correct. Okay. Now try this one. Try this now.
So,
Am I audible now?
you're audible.
Okay. So try this question.
So with dot product of force and displacement, applying the limits from so 1 to 3, 2 to 3, and 1 to 8 you can get next.
So do it. See how you are doing.
Okay. So work done in the z direction will not be significant.
Okay. So just tell me the equation. No need to solve it. What you are integrating, just tell me that equation.
So here the what equals to integral
Hmm.
3x dx I cap from limits 1 to 3
Okay.
plus integral y square dx from 2 to 3
Y
z
square.
component
Y square.
dy sorry sorry.
Okay. That's it.
But z component will be 0.
Okay. Okay. So you can try this one. Just tell the equation. That's it.
So,
So again, same thing we'll do.
yes sir again limit sorry, integration with my limit.
Okay. Yeah. So that is the fundamental thing that you have to do all the time. Okay. So now let's talk about the mechanical energy. Mechanical energy is simply And mechanical energy of a body is simply, or a system is simply, the sum of total kinetic energy plus total potential energy.
Sir,
Okay.
what is potential energy, sir?
So we are going to talk about that. Till now we have not covered potential energy. So just gave you a formula, but now we'll see. So kinetic energy we already discussed, in the last class. Now,
Sir, one can say kinetic energy. Somewhat confusing.
what is your confusion?
Sir, means how it is generating. Still, I'm not getting my help.
How it is,
Generating means
how it is.
how it is coming in. Due to motion, it is coming, sir. But means it is the energy given by the applied force, or we need to consider as the energy given to the body by the net force. We should consider. Sir.
Uh,
There I have a
so
confusion.
why you are saying energy given to the body? No one is giving
Body is
to the body. Body already have that energy because it is
mm,
moving, and it was already moving, and no one started to move it because it was already moving. Something can be moving and will not come to, never started and never come to rest. Moving continuously without any force. Nothing is there, just moving. If you will ask the right question, then I will answer. You will have to ask the exactly what you want to ask. Means when you are saying that who gave the energy, means you are saying that at some time there was no energy, then someone gave energy, but already there was energy, no? There's no need of giving energy because it was moving. So you have to be specific, you have to take a situation and then you can question that. Sir, suppose there is a object, it is at rest and now it starts like that. You'll have to be specific, give me a situation, then only.
sir, if you assume that the body is at uh, from rest if it is starting, so with initial velocity.
How it can start? Body cannot start. How it can start? Tell me, you tell me
With
how it.
with some force on initial.
So then that force is doing work, and that work is equal to kinetic energy, work energy theorem.
That is, that work done by that force is given to the body when it present.
Yes, and that becomes the kinetic energy because of the work done by the external force or maybe internal also, it gains some kinetic energy. That energy is exactly equal. Work energy theorem. What is that?
Yes, sir.
So whatever is the work done, that is exactly equal to the change in kinetic energy. But initially you are saying it started from rest, so that is the kinetic energy. Whatever is the work done. 10 joule is the work done by the force. 10 joule is the kinetic energy. Now what is the problem? Tell me your problem exact. Keep asking.
So,
Keep
but there we
asking.
are saying,
Yeah.
so, but there we are saying that the total energy no, so work done by, if it is
No,
starting from rest, then initial
no.
kinetic energy is zero no, so then
Yeah,
work done
kinetic
by this
energy is
total
zero.
should be considered.
Yeah, so total, that is the total now which you are exerting. Whatever force is acting, that is the total. Means if you are exerting one force, you will calculate work done by one force only. If you are exerting two force, then you will calculate work done by both the force added together. Total.
Okay, sir. Yes.
Whatever is the force acting, you have to calculate work done by all the force. Not if you are taking just work done by one force, then that is not equal to change in kinetic energy. Then it is wrong. Keep asking.
No,
Keep
you are,
asking.
So we said that energy is just ability to do work much.
Yeah. Yes. So once the body acquired that energy, kinetic energy, now the body can do work because body have kinetic energy. So suppose if the block is moving with a velocity v, now if that block will hit another block, can it exert force and displace that other block?
So it can or it cannot depend on some situations.
Tell me any
Okay,
situation where it cannot. Tell me, give me any situation where it cannot.
so if a body is so huge and then a small body is attacked,
If a
then it
body,
cannot.
if a body,
So if a small body of let us take a 1 kg body shifted to 100 kg body, then it cannot move that.
so if it cannot move, then conservation of momentum will not be valid, no?
The momentum is conserved.
Momentum is conserved, then the body there will be some displacement, no? Yeah, there will be very small displacement because, but then the mass is so much so that the work done is large. See, a rate of change of momentum of both the body will be exactly same, whatever be the mass. For example, if this is a small particle and this small particle is going, is moving, and in front of that a small particle there is a very big particle. There is a very big particle. Let's say this is 100 kg particle, and the both of them strike means this body, a smaller mass strikes the bigger mass body. Now here work is done only during that interval in which they are in contact, right? Because when they loses contact, then there is no force, then there is no work done. So the work is done only during that period of time, that delta t time dt time in which they are in contact. And when they are in contact, according to Newton's third law, they exert equal force. So there is no matter of bigger or smaller because they exert equal force on each other. So the force that a smaller mass will exert on the bigger will be exactly same as the bigger will exert on smaller. Are you getting it? And work done is simply force and displacement of the point of application of force. So there will be some displacement. Now, if there is no displacement, suppose, then why it is losing its kinetic energy according to work energy theorem? Are you getting? Its momentum will change. No, its momentum will change. Then kinetic energy will change. If momentum will not change, that is not possible because then that violates the law of conservation of momentum. Keep asking. Keep asking. Keep
Yes,
giving
sir.
counter logic. Keep asking. Till the time you are convinced, you have to
So,
ask questions. Yeah.
so how can we say that this law of momentum is conserved? Sir?
Means I'm saying momentum of this system. That should be conserved, no? Because there is you are not considering any other force. Are you getting? Why it will not be conserved? Give me that logic.
The momentum means product of velocity.
No, no. Momentum means mv, mass into velocity.
It's a velocity and mass. So then,
So there is
sir,
law of conservation of
velocity.
momentum. Hmm. So
So
I'm
then
not saying
velocity
momentum
can.
of the particle. I am saying momentum of the particle plus this block system will be conserved. That cannot change. No, particle plus block momentum cannot change because there is no external force. Momentum of a system. Yeah.
Yes,
Momentum of a system can change only if there is an external force, and there is no external force. When this particle will collide with the bigger block will exert force on the particle, and particle will exert force on the bigger block, which are the internal forces. Now, internal forces cannot change the momentum of the system. Momentum of the system can be changed only by the external forces. There is no external force. So the momentum of a smaller block and bigger block has to be, means the whole system added together. Total momentum has to be conserved. Now, to conserve total momentum, if the particle will lose momentum, the block has to gain some momentum, no, to compensate, so that total momentum remains constant. Now, again, you can ask your doubt. You just pinpoint your doubt, pinpoint your confusion. Keep asking.
It's not confused for the whole system.
Okay. Okay. So now we are going to the next topic, that is conservative and non-conservative forces. So you have to understand that those type of forces are called as conservative if work done by that force is independent of the path, does not depend on path. Listen very carefully, that if work done by a force does not depend on the path. For example, if you take a particle, if a particle goes from here to here and a force is acting, so first time particle goes through path 1 and second time particle goes through path 2, and in both the case, if the work done comes out to be same, and it's not only about the two path, it's about any path. Particle goes from any path from point 1 to 2, but if initial and final point is fixed but path is changing, but if work done by a force in all the cases same, then it clearly means that the work done is independent of the path. Such type of forces we call as conservative force. So what you understood, that work done by a conservative force will be always path independent, means it will not depend on the path. Whereas it is exactly opposite for a non-conservative force, means in case of a non-conservative force, work done will depend on the path. So if you are going from A point to B point by path 1 and path 2 by path 3 by path 4, so then different paths will have different work done, and then it means that the work done is path dependent. If it is path dependent, then the force is called as non-conservative force. Now comes potential energy. Now you can understand potential energy only if you understood the conservative and non-conservative forces, because potential energy is always associated with a conservative force. So what are the conservative force? Gravitational force is a conservative force. A spring force is a conservative force. Electrostatic force, like that. Those forces which do not depend on the path, which are path independent, they are called as conservative force. Now here you have to understand that friction is not a conservative force, because work done by the friction depends on path. Means if you take a body from A to B on a rough surface and then from B to A by some other path, work done will be different. And that's why friction is not a conservative force. Friction is a non-conservative force. Potential energy is not associated with a non-conservative force. It is only associated with conservative force. Now, every conservative force has an associated potential energy. For example, gravitational force is a conservative force, so there is gravitational potential energy. Electrostatic force is a conservative, so there is electrostatic potential energy. A spring force is a conservative force, so there is a spring potential energy. You will never find frictional potential energy, because friction is not a conservative force, so there is no any potential energy associated with it. Now, once you understood the potential energy, conservative and non-conservative force, and you
So
understood,
means
yeah,
so you can say work is if the work is dependent on path is non-conservative. So work done
yes,
by a
yes, and if it is not dependent on path, then it is conservative.
conservative.
Potential energy is always associated with conservative force, and work done by a conservative force only depends on the initial and the final position of the body. No matter you take the body is going from initial to final point by whatever path, any path, the work done will be always same in all the paths. Now comes the most important thing here, which gives a relationship between the potential energy and the work done by the conservative force, and this is the fundamental of understanding all the potential energy. So the equation is that work done by a conservative force is always equal to negative of change in potential energy. Or you can say that the change in potential energy is actually defined in this way, that whatever is the work done by conservative force exactly same as the negative of change in the potential energy. This is the most fundamental relation. So all the potential energy change can be calculated by this formula only. You cannot calculate the potential energy by this formula. Potential energy has no significance. Only change in potential energy has significance. So change in potential energy and work done by conservative force, this is the relationship between them. So if suppose that a particle is going from this point to, let's say, this point, and when it is going from this point to this point, let's name this point as 1 and let's name this point as 2. The particle is moving under the action of a conservative force. So because the conservative force is acting all the time as the particle is going from 1 to 2, so the conservative force must be doing some work. Now whatever work conservative force does, exactly that is equal to change, negative of change in potential energy, and that is equal to minus of change in potential energy. So it will be u2 or u final minus u initial. From here you also understood that whenever conservative force will do some work, it will decrease the potential energy of the system. That's why negative sign is there. Are you getting?
So is that there exists no term called potential energy? So that then how can conservative force can decrease the potential energy?
Speak louder and clearly. You are not clearly audible.
So you said that there is no term called potential energy, potential energy.
There is,
Only
again
change in
louder.
potential exists.
Only change in,
The
yeah,
only change in potential energy exists. Then how
okay.
can work done by conservative decreases the potential energy of systems?
So decrease in potential energy is also change, no? This is decrease in potential energy. Means I said that only change in potential energy is significant, but it does not mean that there is no potential energy. Potential energy is there, then only there will be some change, no? But the thing is
Yes.
that potential energy has no absolute value. That depends on the reference point. Change in potential energy has absolute value. So what I said, that potential energy will decrease, but decrease is the change. Decrease is not, decrease or increase or change only, no? So I'm talking about change.
Yes, sir.
Change is negative, so we say decrease. Change is positive, we say increase. So I'm talking about change only. Okay. Let's go to the next then. Okay, so now here you can see the same thing can be written mathematically like this. For example, you know, if you cross multiply this expression, you will get exactly what I said. What you will get? You will get work done by conservative force,
Yes,
which is
yes.
F dot dx. If you cross multiply F dot dx, and that is equal to minus du, right?
Fine.
Now, if you arrange it and then then you will get that
Sir, this
conservative
is
force
used
is
when the force is changing, no, sir, when the conservative force is changing.
no always
So means
means
it is
if it
integration
is
form,
not
sir.
changing, it will you will take it out of the integration.
Yes. If conservative force is variable, then we use the integration method. That is one.
Means conservative force is not a variable. Like potential energy is a function of x.
Yes, sir.
Okay, so then you can integrate it, and it is actually saying the same thing. So fx here dx should come. This is missing here. Okay, so this is how we define the change in potential energy. Now, if we have to define the potential energy, then we will have to take some reference. For example, if we take, so that will come with the, whenever it will come, we'll discuss about it. I think it will. So you will have at some point, we will have to take a reference that, okay, at this point, we will take the potential energy to be zero. And then only we can find the potential energy at some other point. Means reference we will have to take somewhere. Okay.
Which is a reference. It depends upon uh, any particular situation. So it changes from situation to situation.
So yeah, so reference you have to reference should have some logical uh, reason that why you are taking that as the reference. So
You can say because you said that we should take reference where the potential energy is zero now, sir.
no, but then how you know that where the potential energy is zero? You don't know that no. Means you are, that is the meaning of reference. You assign any particular point that okay, I will call this point that this point has zero potential energy, and that is my reference. But then which point has zero potential energy? That how you will know?
Mm. So that how we can take reference position.
Yes, we can say definitely because the potential energy is always associated with conservative force. Okay, so based on that, whenever situation will come, we'll talk about it. So that is simple, logical. For example, gravitational force is there. So when two bodies are infinitely separated, we will say that okay, we will take the reference as infinity. That when separation between two bodies is infinity, potential energy of that system will be zero. But why infinity? Because gravitational force is zero. So if force is not there, potential energy, there is no meaning. So that is a good choice. But in case of a spring, we will say that when there is no elongation in the spring, we'll take the potential energy as zero. And that is a good choice because when there is no elongation, there is no spring force, no conservative force. Are you getting?
Yes, sir.
It will vary from situation to situation. We have to make a good logical choice, and sometime the question can directly give you that take this point having zero potential energy. Taking this point as reference, calculate the potential energy of that particular point. That also can be given. If we define melting point of ice as 100 degrees Celsius, then what will change? Nothing will change. Boiling point of water will become 200 degrees Celsius.
Yes,
But
sir.
then the
Double
meaning of 200
100.
Celsius is exactly same as 100 degrees Celsius because the reference is 100. Are you getting? Only
Yes, sir.
names and numbers will change. Temperature will not change. Because whether you say it 100 degrees Celsius or 0 degrees Celsius, that is the melting point of ice, which is fixed. Okay, now try this question. Whenever you have confusion, you keep asking questions, keep giving your counter logic. Try this question. No need to say yes sir, no sir, no need to agree with me. Whatever I say, you can question that. You have to question that. Okay, so I think what is the time now? So we already completed more than 1 hour. Okay, this is the last question. You can just try. Yeah, tell me.
Sir, sir, with sir, is there any special meaning for that? Which at each point of the directed towards the tangent of the trajectory, sir?
Yeah, means it is along the tangent all the time. Tangent will
Sir,
be different, no, at different point. That's why every point tangent will be same or different.
the difference in this
That's why.
part is
That's why everywhere it is along the tangent, which means that everywhere it is along the tangent, but the tangent is in different direction. Means the force
okay.
is variable. Force is changing direction, but it is along the tangent.
Nothing GM. Okay. Four dot what was in the displacement. Four we cannot answer. Leptin is it GM. Corresponding every force is the condition. The forces obtained by mg. Sir, here normal reaction will be present also. When we
Yeah,
consider uh, work energy theorem, then we should consider the work done by the normal reaction
all
plus
the force.
mg plus F motion.
Yes,
Three forces we should consider. Okay.
yes, yes.
So then work done by mg plus work done by F plus work done by normal reaction will be zero now. So
No. Again, repeat the same statement. What you said.
so work done by gravitational force mg, work
Okay.
done by external force and work plus work done by normal force is equals to zero now.
Okay. Huh. Yes, correct.
So then work done by normal force will be so then work done by external will be minus of work done by gravity plus normal reaction also. Work done by
Okay.
normal
So
reaction.
what you are getting? Which option?
Data is insufficient, sir.
This is the answer.
What would,
Data is sufficient.
sir, what is,
Is
we
wrong.
should consider work done by the normal action also, sir.
0.
Normal action is work done by,
Work done by normal action always 0. All not always 0, but in this case 0. Normal.
yes, sir, work done, honest. MGH will be the answer, yes, sir. Sir, we
Okay.
cannot say in every case it is zero, no, sir.
No, not in every
Depending
case.
upon the case,
Not
yes,
in
sir.
every case. Okay. So now you can try this question. You can
Multiple PLC, okay, variable, okay, happening with division, potential analysis, gravity, potential of the particle. The D will be the answer, no?
D will be the answer. What they are asking you? No,
Potentiality and displacement graph is, you can position graph.
no. D is not correct.
Sir, inside is mentioned zero, no, sir.
Initial is 0, yes.
So,
But initial is 0 in B also, C also, D also.
I'm developing an equation. Initially zero, so whenever press equals to minus d over
It
d.
can be either B or C. D is not possible.
Minus d over d. Oh, sorry, sir. Declaration. So we get an equation y equals to 8. So B, sir. Option B is correct.
This is the correct
Positive
option.
correct. Yes, sir. Option B.
So now keep solving question. Also start solving questions from SCV and
Yes, sir.
keep
Also,
solving
I
these
start.
questions. Okay. Take this as
Yes.
homework. Take a screenshot and you can just try this one. Okay. Keep solving from SCV. Then we'll continue from tomorrow. Now I have another class. I'll have to join. Okay.
Yes, sir.
Okay. You have any doubt? You can ask.
Since in the last problem, since the normal action and displacement are perpendicular at each and every point, the vector and normal action is zero. So we can
Yes. Yes.
no doubt, sir.
But not work done by normal reaction will not be 0 always.
Yes.
There will be situations where normal reaction is doing work. For example, here, if suppose there is a wedge and the wedge is kept on a smooth horizontal surface, and there is a block which is slipping on it, and now the wedge is also not fixed, wedge will also slip.
Yes, sir. It's the
In this situation, normal reaction will do work or will not do work. Think about it.
See, in this situation, it will do work, sir. Because the body, that wedge also moving.
Yes. Okay then. Any other doubt?
That's no other doubt.
Okay then. Bye.
Thank you, sir.